previous videos, this one, any future videos will be up on my channel. There's a link at the back of the room there. There's a board at the back telling you where to go if you want to start from the beginning and catch up. But yeah, today I wanted to do something a little bit different because I know a lot of people have been having a little bit of difficulty with lighting and figuring out how to get it to work. And I think the best thing to do, I really wanted to try and explain, to the best of my knowledge anyway, how baked lighting actually works in Unity and how to get the best out of it. So the easiest thing to do, I've just started with a completely blank project here. There's nothing, absolutely nothing installed. This is just Unity's basic thing. So I haven't installed Bakery. I'm not going to use Bakery. I'm just going to use the built-in light mapper today. And to get that up, you need to click on Window and Rendering and Lighting, and you'll get this window coming up. I usually dock it over on the right hand side so it's easy to get to when I need it. Don't undock your inspector though, that's not a good idea. And then you've got all these different buttons up here. You've got the scene. This is where you set up all your scene for ready for baking. So the first thing you need to do is create some new light settings. This is just a file where it's going to store all of your settings. And that goes with you. You know, if you transfer your scene elsewhere, you'll need to carry over those light settings. To get started, I would recommend, first of all, to use progressive GPU preview. If you've got a GPU, it will really speed up your render. The quality's not going to be fantastic. It's called preview for a reason. There are some issues with it, but it gives you a good visual representation of how your final bake's going to be. And once you're happy with it, I usually go CPU and do the final bake. If it's a large scene, it can take a long time. So if it's a very big scene, sometimes I just let it run and go to bed. And then the next morning it's done, because it can take several hours depending on the size. GPU is way faster, so recommend that. I also recommend turning off progressive updates and multiple importance. Progressive updates is one of those strange things. It will actually work on what is visible in your scene first and then work on the light mapping everywhere else. So you get to, it's quicker to have a quick look at how things are going because it renders what you can see first. But if you move around in your scene, you'll see all these black spots and it then has to start again and render those bits, and it can be a problem. So I usually just recommend turning those off. Leave these settings all final, they're all as they are, as the default values. You can crank them up to higher values a bit later on, but I'll explain how they work as we go on. We also need to know what light map resolution does, light map pattern, light map size, all these different things are the rest of the stuff you're probably as well leaving, just leave it at the default settings until you learn a bit more and can really feel comfortable tweaking it a bit more to your liking. We'll just go through the basics to get started. At the top, after scene, we've also got environment, and this is where you put in the information that it's going to take information from your main light source, which is always your directional light. There is a directional light that comes in the scene, and this is the equivalent of your sun. So it's exactly as it says. You can see the light rays coming down which are parallel to one another. Unlike a point light, you can add different lights here just by hitting on the plus button up here, or you can right click and you've got lights. You've got point lights, spotlights, area lights. If I was to bring in a point light, it's like the equivalent of a light bulb, and you can see it's got an area of influence. So the light will spread out as far as this and get dimmer as it goes. And you can adjust this, and you can also adjust, if we go into inspector, you can see it changing. The range has gone from 10 to whatever. We'll just set it back to 10. And the intensity of the light is basically, if you think about the wattage of a light bulb. So you can adjust that to your liking. You can also adjust whether or not that light is going to cast shadows. And what I always recommend with every single light source, if you're baking your lighting, is turn it from auto to important. Make sure everything is important, and that makes sure that no lights are missed out from the bake. I don't know if you've ever been in worlds on other platforms where they've had real-time lights. Real-time lights are, well, this is currently a real-time light. And what it means is that it casts light at the moment that the world is loaded, and then your headset has to calculate the light bounces in real time and calculate the shadows and which bits are light and which bits are dark. And the more real-time lights you have, the more calculations and the harder it is on your headsets. And real-time lights are really, really tough on mobile headsets, and never recommend them ever. Always bake your lights if you're able to, because you're going to get a massive drop in frame rate if you use real-time lights. And for this reason, because they're so hard on the system, there's a limit to how many lights you can have in a scene at any one time, or how many lights can actually be lit and working at any one time. Usually it's a limit of, I think it's around 6. And if you've ever been, as I say, on other platforms, and you've gone into worlds where they've had many lights, because it's been a big space, a big world, you'll often see, as you turn your head, some lights flickering on and off. And that is your headset working out which ones it's got to prioritise, because it can only render so many at any one time. You don't get that once the lighting's baked. It's all the calculations are pre-done, and then it bakes it into an image, which is like an overlay, which it overlays over your whole world and casts shadows and light patches. And as I say, it's just that light map is just an image or a selection, a series of images which are loaded in at runtime, rendered on the go in much the same manner as textures are. So in order to make a point light a baked light, we would just simply change that to baked, and then it's ready to go. And normally I would set it to soft shadows, as I say, and important. And I do that for almost every light source that I ever put in. Colour, I usually make it, most of my scenes are indoors, so I tend to give it a slightly yellowish look to kind of look a bit like an incandescent bulb, or maybe a flame, like a candle flame. But you could make it any colour you wanted, really. Anything will do. So I'm just going to get rid of that light because I don't want it at the moment. The reason I brought in a point light was because I originally was going to explain that the light goes out in all directions from that point. Whereas, I've just duplicated it, I meant to delete it. Whereas a directional light, it's just parallel rays that all go in one direction. It doesn't matter whereabouts this directional light is in your scene. It's as if it's all coming from like everywhere, but only in one direction. And while it is on mixed or real-time mode, it will actually go through walls. So I always set that to baked as well. And then if you've got an indoor scene and the light is very dim, it's going to be dim. You're not going to get light coming from outside through the walls. And I always set that to important as well. So that's my real-time light. What else was I going to say as well? Oh yes, there's also the skybox. It will also take the skybox into account. So whichever skybox you use, it will take colour from that as well, and that will affect your objects, and will also affect your reflections unless you have a reflection probe baked as well. if you have a real-time reflection probe, unless you change some settings, it's only going to reflect the skybox and not the objects in the scene. As I say, there are a few settings you have to change, but once you bake that as well, that's going to be a lot easier on the system, because you'll bake it to a cube map, which again is just a texture which is applied in a specific way. What else have we got? Real-time light maps, baked light maps. This is just where you can view, I never use these buttons to be honest, but this is where you can view your information about the light maps once they're all done. But usually I just keep the scene open and use this as and when. And in order to get light maps baked, once you've got everything set up and you've told it your light sources are to be baked, you then start bringing in your assets. So all I'm going to do to start with is bring in a plane, because I'm going to put a few things on the plane. We'll just hit reset there to put it back to the center. And it's just got the basic material. I'm using a Unity plane just because it automatically comes with a collider and it automatically comes with a light map as well. So you don't have to do anything with it, it will just work. And in order to get it to work, you either click the Contribute Global Illumination tick, which tells it that it's to receive global illumination using light maps. You can set it to light probes, but we're not going to use light probes, we're going to bake it into textures. Light probes are very, very useful for dynamic objects like avatars, like animated objects or grabbables, anything that you can pick up and move around. You might want that to be affected by light and shadow, and so you would use light probes. So the lighting information is baked into, like, it's kind of like using a light map, but where that is like a flat image which is overlaid your objects. Light probes contain information, and it's almost like having information in 3D world. So you can go up and down, forwards, backwards, wherever, and it'll always be affected by the light. You'll see once I've ticked this, contribute to global illumination, that we get a little dash up here under static, and if we pull that menu down, you can see out of everything you can choose, we've got contribute GI ticked. When you come to actually uploading your world, you would normally, in most cases, also tick occluder static and occludee static. And that's for when you come to do your occlusion culling, which I've covered in a previous video. Batching static, if you want to batch everything, there's a couple of different ways of getting things working. You could leave that alone, but normally I would recommend ticking batch and static, because what that does is, if you've got several objects all with the same material, on loading, Unity will combine all of those objects and import it all as one single mesh, and then it only has to apply one material, and that will improve performance. Depending on the size of your world, if it's a massive world with hundreds of thousands of different objects with this material, then it's got to load a huge mesh into memory. It's then got to render each small individual mesh, so it's kind of holding twice the information in memory in one go, and batching might not be the way to go. In that case, I would recommend using GI instancing if you can do. And that is very, very useful if, for instance, you have a garden full of flowers. You might have a flower model and you want to duplicate it many, many, many times. You would instance that flower. So you're using one mesh and one material, or however many materials, but for that one object. But you're instancing it many, many, many times, and then Unity will load in that one object just the once, but it's also given this information telling it, right, you've loaded in this mesh, you now need to render it here, 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 and here, and it gives it all the transform information. So rather than having one mesh with 100 flowers, it's it's got one tiny mesh with one flower, but rendering it 100 times, if that makes sense. So that's GI instancing. This is just going to be very small. I would normally take bat extraction. Navigation static we don't need because we're not going to have like nav paths or anything. It's not a game we're building. Off mesh link generation. Oh, I haven't said that. It's off, isn't it? Off mesh link generation. I'm confused now. I can't remember. Reflection probe static. We do need, if we are going to use a reflection probe, you definitely need to tick that. And I would tick that even for non-metallic objects, because even if it's got a little bit of shininess to the surface, a reflection probe's going to make a difference and add a whole new dimension of realism to it. So that's basically getting set up. When you come to testing your lighting, in the beginning, I usually use auto-generate, simply because it's quick and easy in the very start. And this is how I set up the light maps for all of my assets separately. And then I'll turn off auto-generate, turn everything on as static and bake the whole thing in one go. So I've basically turned on auto-generate, it's baked a light map, it's 0.7 megs in size, and it tells you down here that it's one directional light map, which is 512 by 512 pixels. You can change your light map size here. So if, for instance, you find that you're having many small light maps and you think, well, rather than loading in 8, for instance, 1K light maps, I could load in 2K light maps instead. So you could change this from 1K to 2K, and you've lowered your draw calls, basically, if that makes sense. Because you've only got to actually load in and render 2 textures rather than 1. But you'll see what I mean when we come to actually do it. The light map resolution, that just tells you how many texels per unit, and one unit in Unity, I believe, is a meter. It's like one of these squares, I think. So you would have 40 texels. A texel is kind of like a pixel. It's just a fancy word for it. But because it's not, we're not actually talking about a colour pixel on an image, on a texture. We tend to call it a fancy name. We've got texels, we've got voxels, which are to do with volume, and I like cubes, but yeah, we'll not get into that. So it's 40 texels per unit at the moment. We'll leave it at the default. It doesn't show anything on here because we've got nothing to cast a shadow at the moment. But if I was to bring in a cube, and we'll just reset that to the beginning and bring it up a couple of clicks. And then that one, we're also going to, I'll just hit tick and just tick everything, mark that as static. And now you can see that we've got a shadow on the ground and we've got a darker area on this side. And if I untick auto generate and then turn off the directional light, you can see it makes no difference at all, because these shadows are now baked into a light map. And we can look at the light map by selecting the plane. And if we just double click here, this is the mesh for the plane. The yellow mesh is always that's the UV, sorry, for the plane. And it's whichever one you've got selected. So if I select the cube, you can see the UVs for the cube. And this is the UV for the plane. And when we zoom in, you can see each of these little squares, this little grid, each of those is a texel, and that texel is coloured in a colour, and that shows you the colour of the object, and or the light that's reflected rather, and the colour of the shadow. Doesn't have the colour of the object, but it will if you, once we get coloured items in, you get like screen space reflections and stuff. Don't know if you want me to explain screen space reflections. Imagine you've got a red ball floating above a white floor, and you've got a light which is bouncing off the red ball and onto the floor. Not only will there be a shadow cast, but you'll also get a slightly reddish hue because the colour from the ball is also reflected just a little bit into the shadow on the white, and that's what we call a screen space reflection. So you get that baked into the light map as well. If I go to the box, you can see one side of it is black, and that is the underside. That'll be the darkest part. And as we go around, you can see we've got very light sides and slightly darker sides and slightly darker sides, etc. So that is how it is literally just a texture. It's an image, and you can see that by, if I can, oh goodness gracious, lighten, baked light maps. No, that's just opened it up. Where does it save the light maps? This is what I can't remember. Light and data asset, none. Okay. Can't remember where you go to have a look. It's so easy in Bakery because you get a folder saying Bakery light maps and you can open it up and see everything. But yeah, we'll find them. We'll find them. For now, what I want to do is also show how to bake lighting for assets that you might have downloaded and you can't seem to get it to work. This is a really, really common problem, but sometimes you could get an asset that when you try and bake the lighting, it just looks awful. It's blotchy or it's black, and no matter what you do, you can't get it to work. And there are always workarounds. So I found a one earlier on this afternoon, which is a perfect example. This is a nice little asset, but it's not really set up. Well, it's not set up at all for baking your lighting, which is a bit of a shame because it means that you have to do a bit of work to get it going properly, but I'm going to show you how. So it's, if you want to have a go, it's just on the Unity Asset Store. It's by Ultrasonic, it's free, and it's called Simple Low Poly Decorative Plant Assets. So I'm going to open that up and get it installed into my scene. There we go, import and import. And that's how quick it was. It's a really small file, but you get some nice little things. And in here on the Ultrasonic folder, you've got all your materials that are used. It's got it all filed nicely. You've got all your meshes that it uses. You've got all your prefabs. Well, I should explain prefabs as well at some point. I don't know if I've done that. Demo scene, we'll not bother with that. And the textures that are used in the material. There's only one because it's actually atlased. Every single object in this kit, shall we say, has got its own texture, and they've just put it all in one atlas. One just makes it a lot more performant. So I'm going to get rid of this cube because we don't need it, and I'll just turn on me auto generate again so it gets rid of the shadow. And we'll turn on the light. That would have been a good idea. There we go. And we'll bring in, we're going to use the prefabs just because they're set up already. But I'll show you how you can make your own prefabs and stuff as well. How we're doing for time, past. Right, okay. So I've just brought in flower 1. I can press F to zoom in on it and have a look at it. Nice little flower, quite cute. The only thing I don't like about it is that the leaves are single-sided, meaning that you can see them from one side, but as soon as you go to the other side, it disappears. It's invisible. So we're going to fix that. The flowers are quite nice, although those funny veiny bits kind of look like an eyeball, don't they? That's a bit weird. But anyway, it's a nice little flower. And I want to bake the lighting on it, so we'll hit static. And straight away we've got a warning here. This game object has overlapping UVs. Please adjust mesh importer settings or increase chart padding in your modelling package. If we double click on that to open the preview, and we need to zoom in on the yellow bit so we can have a look at the UVs. They're very small. You know what? I'm going to increase the scale in the light map. And I'll explain that in a little bit as well, but that'll just make them a bit bigger and easier to see. And you can see we do have overlapping UVs. As clearly this bit is a leaf. That has to be a leaf. And this bit here has to be the stem. Don't know what these triangles are, but we've got a triangle overlapping the leaf and we've got a stem overlapping the leaf. And then here, goodness knows what's going on here. But it looks like we've got both sides of the flower, because that is double-sided, the flower. And we've got both sides occupying the same space, because clearly it's using the same texture on both sides of the flower. So the UVs are on the same texture, shall we say. And that's not what we want, because you can have overlapping UVs on a texture UV channel, but you can't have overlapping islands on a light map channel. You can reuse textures on the same island, so it doesn't matter if they overlap. But when it comes to calculating shadows, it needs its own space, because this is going to have different shadows to the leaf. So it can't bake two sets of light information on the same space. So you have to have separate islands with a decent amount of padding between each of them. And the padding is the space between the islands. That's to prevent any light leaking. If you had two islands that were so close together that the edges were actually occupying the same texels, you will get shadows and light information from one island bleeding over into the other island, and then you get weird black lines and splotches where there shouldn't be, and it just looks awful. So you've got to separate them enough that they actually get their own information, their own shadows, their own lighting. So clearly, because of this, it either it can't have its own light map UVs. It's using the texture UVs to bake the light information on, and everything, if you're going to bake lighting, needs its own light map UV channel. And we can do this in one of two ways. You can either I'll just do it on the default cube here in Blender. When you bring in a default cube, it will have its own UV map. That's the texture channel. The first one is always for textures. And if you go into UV editing, you can see its island there. That is your box, unwrapped, ready for texturing. In order to create a light map channel, you want a second channel. So first one's always textures, second one's always light maps, at least for Unity. You can use the channels for anything you like in Blender. But if you're ever creating your own light map channel, you create one in Blender. If you're doing it in Blender, then that will be used for baking your light maps in Unity, always. So you can either do that, or you can go to your FBX file and get Unity to automatically create a UV channel for light maps. I don't normally recommend that because Unity doesn't usually do a very good job, but that's what I'm going to do today for speed, just to show you that you can do it this way. You can make it work. It just takes a little bit more work. And that, you know, you can, there's ways around it. There's always ways around it if you're struggling with an imported asset. So for this, I've got my object selected and I'm in the inspector and I want to hit select, or you could hit the mesh thing here, but either one will do, and it'll take you to the folder and the asset and be highlighted as what it's using. And in this case, it's just using a prefab because that's what I brought in. So now that the prefab is selected in the inspector, we can either, I'm not sure what will happen if I click on open. I don't think I need to do that. No, that'll just open the asset on its own. I'm going to go through assets anyway, but I would normally click on the mesh here, flower one, and that'll take you normally to your FBX or OBJ file, but in this instance it doesn't. It says decorative plant assets meshes, and it says up here it's a mesh, but it doesn't have, there's nowhere where I can like add materials or add just the UVs or anything. It's got nothing I can change about it. And the reason, if you have a look down here, is because it's an asset file. It's not an FBX file. And this throws a lot of people off. They think, oh no, I can't edit it. I can't do anything with it. I can't use this asset. You can, you absolutely can. We just need a little bit of jiggery pokery. So what we're going to do is up here in window, open up your package manager, go into the Unity registry and search for FBX. And you get something called an FBX exporter. Install that. Just wait for it to finish. And once it's done that, you can select your object, and under game object you now get these new options, and just choose export to FBX. And you can see it's automatically going to put it in the assets folder. You can change that and put it anywhere you like, change the name, whatever, but I would recommend leave it as it is. Only thing you need to change is the export format. It needs to be binary because we're going to bring it into Blender and fix some stuff as well, because I want to fix those horrible one-sided leaves. So once you've changed that to binary, Blender doesn't accept ASCII, it only accepts binary. So just hit export, and then you can go back to assets and you've got a flower. So whereabouts, I would like, you might find that you've already placed your flower exactly where you want it. In which case, I might just, for instance, pop it over here. So what I'm going to do is just copy where it is. In fact, we'll even rotate it a bit as well, just to show this works. To copy where it is, hit transform, copy component, and then you can delete that, and we'll bring in this one here that we've just exported, which is an FBX file. Transform, paste, component values, and that puts it exactly where it was at the right rotation before you deleted the asset. So there's the flower. What we want to do now, I'm just going to mark that as static as well so we can see it adjusting in real time. And you can see the flower's all black and oh, it just looks horrible. Now the flower could be black for a variety of reasons. Again, it could be because it doesn't have a UV channel, so we're going to fix that. You click in the assets on your FBX file here. Now we've got these options. If you expand it using this little arrow, you can see we've got some embedded materials, which we don't want to use. We need to use the proper materials, because otherwise, if if you never apply the correct materials and it always use the embedded ones, if you have 10 objects with the same material, it's actually 10 materials. It's 10 different copies of the same material, but you know, it's got to load in 10 materials. That's not what we want. We just want to use whatever it needs out of here. I don't know if that makes sense. But this is what I always do. Just get rid of these, and I do that by having a look and see which materials it needs. Plant 1 and plant 3. So we'll go into materials. We've got plant 1 there, plant 3 there, and apply. And when we go back, you'll see that the materials have gone now. We've only got a mesh, the mesh data in the FBX, and that's all we want. And then under model, if you scroll down at the bottom, we've got generate light map UVs. We'll tick that and hit apply. And then it'll recalculate. Now it's using the correct UVs. So I'm going to select the object because the flower's still black. Double click on that and open. Goodness gracious, let's make this 10 times bigger again and let it rebake just so we can see it a bit better. Now you can see it's got a proper UV. There's a lot of space between all the islands. Too much space in my opinion, but there you go. It doesn't need all of that. It really doesn't need all of that space. This is one of the reasons I don't like Unity's automatic light map UV generation, because it does do exactly this. It creates tiny islands. So when you think about how many texels per island it's using, you're going to get very blocky, jaggedy shadows, which are going to look awful. And then all of this space is wasted. If we had the islands that were much bigger and had just enough space to stop light bleeding through, we'd have much higher quality shadows and smaller light maps. So this is why I always do my own light maps in Blender, but for ease, for simplicity today, we're just using Unity's own built-in. I'm just going to set that back to 1 for now. So the flower's still black. It shouldn't be. We need to find out why. So we're going to bring it into Blender. And to do that, we can just right click on the FBX, show in Explorer, and there it is there. So in Blender, we'll just delete the cube and import FBX, and the easiest way to get it in is just drag and drop somewhere on the dialog box, and you'll see it's there. Flower 1, it's in the right folder, import, and we can zoom in on it by pressing the period key on the numpad. So there's our flower. Now we're going to have a look at the face orientation, because that's the other thing that can cause it to be black. So just pull this little arrow down and tick face orientation. Straight away we can see we've got issues. It should be blue. Blue is the way the normals are facing. So every single face, every single polygon in a mesh has a normal, and the normal is the side that is rendered and the other side isn't rendered. So if the normal's facing outwards blue, that'll be rendered. Anything red won't be rendered. So that's why the leaves disappear in Unity when you look at them from the back, but you can see them from the front. And that's because this is not what they call a manifold mesh. A manifold mesh is a fully enclosed, like a box, without a side missing. It's more like a plane that's just been deformed. So we can show that by selecting a face on the leaf. And if you go to the other side and you can see the face selected on the other side, you know that it's just a single layer. Whereas the flower, we can select a face, and when we go through the other side, it's not selected. So we know that the flower's double-sided, but what's happening, because the faces aren't being rendered the right way, we're actually, when we look down from the top, we're seeing the underside, and when we're looking up from the, from the bottom, we're seeing the top. And because we've got these two faces looking at each other, pointing, like facing each other, very, very close together, it's very dark in there. It's like having two walls pushed up next to each other, and it's just all shadow, and that's why the flower is rendering as black. So we want to flip those faces round. So what we do is just hit L, which will select all the linked faces, because I can tell that that flower is a separate object and not linked to the stem. And then we can press Shift and N, which will recalculate the normals, and it's recalculating them to the outside. If I ticked inside down here, it goes back to red, but we want them on the outside. So that's correct now. The only thing I want to change is these leaves. I don't like the fact that they disappear from the other side. And rather than creating a double-sided shader, which I don't think's, I don't know, I think because this is such a simple mesh, I think it would be easier on the system. Like, it doesn't have to do any extra calculations really, just to duplicate this mesh, and I do that by pressing Shift and D, and I've got a duplicate, and if I hit escape they just snap back to where they were, and Shift and N to no, it's not Shift and N I want to flip. This time it's Alt and N, and then you've got flip. You can either hit F or choose that at the top of the menu. And now we've got two sets of normals. So we've got one set facing inwards and one facing outwards for the leaves, but they're just going to have a single-sided material on it. So now let's just come out of face orientation mode. Only other thing I don't really like is this weird shading that it's got. I usually fix that myself and make it look the way I want it to look. So for this, if you've got weird shading, you could try shade flat. May or may not work. If it doesn't and you get really weird look to it, just come down here to under the green triangle, which basically means all the mesh and normal data and UV data. Under geometry data, just here, hit clear custom split normals data, and that should get rid of any weirdness that's going on. So then I would normally shade auto smooth, and under normals, so auto smooth will only smooth anything that has an angular difference, any faces of 30 degrees or less, and anything over that won't be smoothed. So these lines here obviously are over 30 degrees. You can crank this up if you wish, and I can keep cranking that up, but normally I wouldn't recommend going above, well, it depends on what you're doing. Boxes, you wouldn't go above 90 degrees, otherwise you're going to end up with really, really weird shading, because that lovely sharp edge on the corner of a box needs to have that 90-degree crease. So I could even say 89.9, and it's still going to do everything under 90 degrees. So we've still got an edge on the flowers, which actually I quite like. So we're going to export that. And I'm just going to do the same thing here. Drag that in there. Selected objects. Yeah. Export FBX. Let's see what's going to happen here. And look at that. We can see the leaves from both sides. And we've got light reflecting off the flower, exactly as we want. The only thing is, it doesn't really look like it's got any shadows going on, because it's so tiny. And this is why I wanted to explain the scale and light map setting. So it's still saying it's got overlapping UVs, and I'll show you why. If we open that, actually, you know what, let's turn off the plane so that we're only looking at the flower. If you pull this menu down where it says baked light map, and choose baked UV overlap, you've got all these red bits here. And you don't want that. That's why it's saying it's got overlapping UVs, even though it hasn't, because these islands are so close together and because the resolution is so low, it's showing these red areas where it's if these islands were actually touching these red bits, it would be sharing light and information. So in that case, what you would normally do is either do it manually in Blender, but because we've generated it in Unity, it's easiest to scale the light map. So we can, for instance, double it in size. It's doubled the texel density, and it's got rid of the red bits, and we don't have the yellow warning saying we have overlapping UVs again. It's still not a very high texel density for what it is. It is only a tiny flower, and in normal instances, I would just say you're hardly going to notice that. That's just one of those tiny little things in the background that decorates the place. It's not important, and I wouldn't do this, but I'm doing this just for demonstration purposes. So I could make it 10 times as big, and that's really increased the texel density. That's looking loads better there. I mean, you could go as high as you wanted, depending on how much information, how many meshes you've got in your scene, how much big your light maps are going to be. At the moment, with a scale of 10, I'm now up to 42K, but that's not including the plane. Let's turn the plane on, because that's going to whack it right up. That's a big plane, that. So now it's 2.7 megs, because we've baked a light map for this huge thing and this tiny little flower. Why is it not zooming in now? There we go. If I was to increase that to 20 and zoom in, you can see that the UV for the flower is getting on for almost as big as the UV for the whole plane. So that is massive, but you can see there you've got a lot more to work with as far as calculating and casting shadows goes. So we're just gonna, let's just set that back to 10 for now. How we're doing for time? We've got a few minutes still. So we'll bring something else in and see if we can fix that as well. Which one did I do? It was flower 1, wasn't it? Let's try flower 3 and have a look at that. And we'll rotate that a little bit as well. There we go. We'll set that as static. Got the same issues. Flowers black again. Leaves are invisible from the back side again. So we'll export it as an FBX again. Set to binary. Export. I'll just copy where that flower is. Copy component. And then I'll delete it. We'll bring in flower 3. Paste. Component values. Set that as static. Flower 3, generate light map UVs. Still black. And if we have a look, let's make that 10 as well, because it makes it easier to look at. And that one, we do have, doesn't look like we've got any overlap and stuff. We do have separate islands. but we've clearly got an issue going on with the normals again on the flower. So we'll just close this, right click that, show in Explorer, we'll hide that and we'll bring that flower in there. Face orientation, yep. So select those, recalculate, and then the leaves, duplicate and flip. And then we can export it and we'll just overwrite flower 3. And there we go. Still don't like that weird shade, and you see that weird thing that's going on with the petals there. I really don't like that. So I'm going to do the same thing, clear custom split normal data. That's fixed that. We'll do auto smooth. I'll just bump that right up again because I can't be bothered to fiddle on with it. That looks a lot better. So export flower 3, and now we haven't got that weird sheen that I didn't like before, and it looks way better. We can see the yellow in the center of the flower. So we have successfully got some light maps working. Make light maps. I wish I could remember how to open up the folder for the light maps though. I'm sure there used to be a way of just taking you directly to the folder. But it just opens up a preview now. Never mind. It's working. You can see the colours, you can see everything. Let's just have a look at baked light map there. You can see on here, even on the plain light map, there's the shadows of the flowers. Now if I was to turn up the texel density in the lighting settings to say, I don't know, let's double it and say 80. You'll see this be far less jagged. You can see here it's looking quite jagged. Now we've got a lot more resolution. You can see the individual petals. And there's absolutely nothing wrong with turning up your texel density depending on the size of your space that you're building. You can see now, when you think all I've gotten here at the moment is a plane and 2 flowers and it's already at 5.3 megs. That's because I made each of the flowers 10 times as big as they were, just so that we could see the UVs properly. And then I've increased the light map resolution to 80 instead of 40. And we're up to 5.3 megs just for this. It looks lovely. It looks absolutely lovely, but it is so overkill. You really do want to try and get away with a smaller light map as you can. Keep your texel density as low as possible. Keep the scale of your objects as low as possible. Sometimes I find what I do, let's just open up baked UV overlap again and we'll select a flower. And we'll set that back to 1. Am I going to get an error with that one, I wonder? No, of course I'm not. Let's try that one. Not that one either. And you know why? It's because my texel density is at 80 now. Let's change it back to 40. Because what you can do, you know, is have a really low texel density, like 10 or 20. And then, see, this is all red. only the items you need to increase you can, and have them like the minimum scale that you can get away with. You could do that. Let's change this to 20. So the scale, this is all red and I've got an error. You can just increase the scale until it works. 10's too much. Let's try 5. And instead of keep clicking and adding numbers, you can add, like, you can put -1. Keep making it smaller. -1. That's okay. -1. Now we've got an error, so plus 0.5. That's got rid of the error. -0.1. And just add and subtract little bits until it kind of looks right. And that's about the smallest I can get away with without having any problems. So yeah, light map resolution is your texel density, texels per unit. That affects everything in your scene, but then individually you can adjust the texel density on each object just by adjusting the scale of it in the light map. So you've got full control over it, and it does mean that you can, with a bit of time and a bit of patience, you can adjust everything until it's at its optimal. You're getting, it's all about balance. Also, another thing as well, if you see something, then you're getting an error saying there's UV overlaps, just have a look at your object. Don't bother looking at this. Don't bother worrying about that. Just look at your object and say, well, can I see any problems? Is there any black, are there any black bits or any blotches, or is there a blob of light coming from somewhere that shouldn't be there? If you can't see anything and it looks fine, don't stress over it. It really doesn't mean that it needs to be fixed. Just because you're getting a warning doesn't mean it needs to be fixed. So yeah, that's basically it. Oh, another thing. Yeah, I'm not quite done. Sorry, I know it's after 8. Your flowers, your different objects that you have, when you come to import them, when you get many objects, what I usually do is I'll work on one, I'll get the texel density right. So on this one, I'm going to say 2, +1, +1, +1, no, still getting there, -0.5, +0.1, just keep adding until it gets there. There we go. Dead on 5 for that. And once you're happy with that, just untick it and move on to the next one. And that way you're not baking everything in one go. The bigger your world gets, just work on each item one at a time. See if you can get a rough idea of how big it needs to be in the light map, if you have to adjust it at all. And once you're happy with everything, just make sure everything's ticked and you're good to go. It'll bake everything. You don't have to use auto generate. It's just handy to keep that turned on while you're doing one item at a time. And then you can turn this off and just do your final bake with your progressive CPU. Crank these up. I usually use subtractive as well, but crank these up a bit. I usually say multiply by 4. Your samples is to do with basically
later,
the
y'all.
amount
Talk
of
to you later.
time.
Gotta go. Sorry.
Okie dokie, bye. Yeah, samples is to do with the amount of calculations it's doing, so, and the number of bounces as well. Basically, you want to have as many photons, as it were, if it was the real world, bouncing in between objects as much as possible, so it gets as many calculations as it can and makes much more accurate calculations as far as illumination and shadows go. So you crank these up. It is going to take longer, but it won't increase your calculate. Oh God, it will increase your calculation time. It won't increase your light map size. So yeah, as I say, crank these up nice and high before you do your final bake, and you'll be impressed at how good your shadows are. But yeah, that's basically it. I think I've covered everything. I've been deserted though.
Thank you so much. I appreciate all that.
Just a bit. Yeah,
I know I've not really covered light maps and shadows much in the past. So I thought it would be a good idea to cover them anyway and give people a few tips and tricks to get the best out of the lighting. But yeah, I shall stop the stream. Thank you for coming along. It's not a stream. I always say that. It's not a stream, it's a recording. It will be uploaded to my channel.
Okay.